Welcome to Learning with Philemon. In this video, we will be looking at carboxylic acids and the process of esterification. In the previous video, we learned that primary alcohols can be oxidized to carboxylic acids using the acidified oxidizing agents potassium manganate ViI or potassium dichromate Vi. However, ethanol can also be converted to ethanoic acid, also known as acetic acid, by bacteria in the presence of oxygen. This process is known as acetic fermentation. This can be seen in everyday life if wine is left exposed to oxygen for a long time. Eventually, the wine turns into vinegar, which consists of ethanoic or acetic acid. Carboxylic acids contain the functional group COOH. As can be seen in the structural formula of ethanoic acid, this means that the carbon on the end of the carbon chain has a double bond to oxygen and a single bond to a hydroxyl OH group. Due to this functional group, carboxylic acids are weak acids. In aqueous solution, carboxylic acids partially dissociate. Let's look at ethanoic acid, for example. Partial dissociation means that a small proportion of the ethanoic acid molecules lose a proton, an H+ ion, to form the ethanoate ion, CH3COO-. Because not all the ethanoic acid molecules are converted into the ethanoate ions, the reaction does not reach completion. This is why we see a double-headed arrow in the equation, indicative of an equilibrium, rather than a single-headed arrow. For more on the double-headed arrow, please watch the equilibrium playlist. Substances that give out a proton are considered Bronsted-Lowry acids. For more on acids, please watch the videos in the acids and bases playlist. Now let's look at how carboxylic acids react with alcohols. Carboxylic acids can react with alcohols if heated in the presence of an acid catalyst, such as concentrated sulfuric acid. In the example below, we see ethanoic acid reacting with methanol, CH3OH, the ester methyl ethanoate, CH3COOCH3, and water, H2O, are formed. Note that yet again the reaction is in equilibrium, so a double-headed arrow is used. As can be seen in the structure formulae below, the methanol is added to the ethanoic acid. In the process, an OH group from the ethanoic acid and a hydrogen from the alcohol are lost. The OH and the H groups form water. Esters contain the functional group RCOOR-. This means that the carbon in the middle has a double bond to oxygen and a single bond to oxygen. Esters are different from carboxylic acids because this oxygen is not bonded to a hydrogen, but to another carbon. In this case, the oxygen is bonded to a methyl CH3 group. The carbon with the double and the single bond to oxygen may be bonded to a hydrogen or a carbon. In this case, it is also bonded to a methyl group. The R and R' represent either a hydrogen atom or a carbon chain. Esters get their name from the carboxylic acids and alcohols they are formed from. The beginning of the name comes from the alcohol. Methanol changes to methyl. The end of the name comes from the carboxylic acid. Ethanoic becomes ethanoate. Whereas carboxylic acids have strong sour odors, esters have fruity, pleasant odors. Many of them are used in perfumes, essential oils, food flavorings, and cosmetics. Thank you for listening. To consolidate your learning, try to answer the questions in the description. If you haven't already, please subscribe for more content. Stay curious.